Hmm. Welcome dear students, welcome to the class once again. Today we are going to start the types of redox reaction, and in the last class I introduced you to what are redox reaction and general terms associated with redox reaction like oxidation, reduction in terms of electron transfer, in terms of oxygen addition, in terms of hydrogen removal, and also for reduction I told you that it is either the addition of an electropositive element or the addition of electron or the removal of oxygen. So we came to know all this. Now today we are going to study about your today we are going to study about the types of redox reaction. What are the different types of redox reaction? So these are the different types of redox reaction that we are going to study about this. Now let's see. So let's see what are the different types of redox reaction. Let's begin with it. So the first type of reaction, redox reaction, is your combination reaction. Now what is a combination reaction? This one you have studied in your class 10. That a combination reaction, it can be denoted in the manner by this. See, A plus B, if it is forming a single compound, that is C, then that is known as a combination reaction. So here either A and B or both A and B must be in elemental form, means either of them should be in elemental form for such a reaction to be a redox reaction. All the combustion reactions which make use of elemental dioxygen as well as other reactions involving elements other than dioxygen, they are redox reaction. So some important examples of this category are this one you see here. This is in the elemental state. Similarly this one O2, this O2, this is also in the dioxygen in the combustion state or in the elemental dioxygen state. So these two are reacting together and they are forming a CO2 molecule. So this is the example of a combination reaction where two atoms, they are combining together and they are forming a single compound. Next is your decomposition reaction. Now decomposition reactions, they are the opposite of your combination reaction. Precisely, a decomposition reaction leads to the breakdown of a compound into two or more component. At least one of them should be in their elemental state. You see here, this is your sodium hydride here, sodium hydride. Now this is, you see here, this is in the elemental state and this is in the molecular state. So the condition for a decomposition reaction is that at least one of the compound that should be present in the elemental state. So here your sodium is present in the elemental state. Now this another one is your displacement reaction. Now in displacement reaction, an ion or an atom in a compound is replaced by an ion or of another element. It can be denoted like this, you see, X plus YZ, it is forming XZ, means there is a change, interchange is there. Now this can be again divided into T categories, that is metal displacement. A metal in a compound can be displaced by another metal in the uncombined states, as in this example you see here the metal copper, this is in the combined state with sulfate and this zinc is your alone. So now metal displacement means this zinc will come and displace this copper from here. So you will get here copper and zinc sulfate. So here what is being displaced? Metal is displaced by another metal. So this is known as a metal displacement reaction and this is the subcategory of displacement. Another one is your non-metal displacement. Now non-metal displacement means here one non-metal will be displaced, which may be hydrogen, and a rarely occurring reaction involves oxygen displacement also. You can see here, you see non-metal, here a non-metal is displaced. Which is the non-metal here? Oxygen. Now oxygen is a non-metal. Now this is displaced from water, it means it is coming to your sodium here. So the non-metal displacement redox reaction include hydrogen displacement and a rarely occurring reaction involve oxygen displacement. Here oxygen is displaced, so this oxygen is coming here, so this is a non-metal displacement reaction. Now last one and the most important category is your disproportionation reaction. Now in disproportionation reaction, these are a special type of redox reaction. Here the element in one oxidation state is simultaneously oxidized and simultaneously reduced also, means both the reduction and oxidation will occur with the same element in the same reaction here. Now how it is that? You see here, one of the reacting substance in a disproportionation reaction always contains an element that can exist in at least 3 oxidation states. Means minimum 3 oxidation states should be possible in the reactant phase. Now the element in the form of reacting substance is in the intermediate oxidation state, and both higher and lower oxidation state of an element are formed in the reaction. The decomposition of hydrogen peroxide is familiar with this one, you see here. In this case, now here you can see the oxidation here, the disproportionation of oxygen you see here. Here hydrogen peroxide, it is decomposed to water and oxygen here. Here oxygen is experiencing disproportionation reaction. How disproportionation reaction, you see. Now for this you have to know that what is oxidation state, and we have to calculate the oxidation state. Now how to calculate an oxidation state for a certain element present in a compound. Here the oxygen of peroxide is present in -1 state. Now I'll be teaching you how this -1 came. It's converted to 0 oxidation state in O2 and decreases to -2 oxidation state in H2O. Now I'll show you that how it is happening here. In this compound, the oxidation state of oxygen here in hydrogen peroxide, it is -1. Here only one type of oxidation state is present for oxygen, but in the product phase you have two places where oxygen are present, and in both places the oxidation state is different. Here the oxidation state is 0 and here the oxidation state is -2. And now we will be looking at how to calculate the oxidation state. I'll be giving you different examples and we'll be looking into it, that how do we calculate the oxidation state. Then suppose we have to calculate the oxidation state of oxygen in case of water. Okay, then here for the element for which you have to calculate the oxidation state, we consider it as X. Okay, and this water molecule, it does not have any charge on it. Now if you remember the rules that was taught in the previous class, it was said that the sum of all the oxidation state for a neutral molecule is always equal to 0. So now we don't know the oxidation state for oxygen, we have to determine it. So this will be X. Now plus, now the thing is that how many hydrogens are there? Hydrogen has 2 hydrogens are there, so we will write here 2 into. Then we know that what is the charge of hydrogen present. So hydrogen, it accepts 1 electron, means it always needs 1 electron, so it means that it has a charge of 1, that is equal to 0. So now if you substitute this from your normal maths, you will get X is equal to -2. It means that here the oxidation state of oxygen is -2. Now if I am calculating this for H2O2, then let us see here. We have to calculate for oxygen. So this oxygen we have to consider as X. Now how many oxygens are there? 2 oxygens. So we will write 2 here, twice X. Plus, now once again here how many hydrogens are there? 2 hydrogens. So once again 2 into 1 equal to no charge on the compound, so that will be equal to 0. So this will be twice X is equal to -2. So X is equal to -1, and that is why it is written here. It is written here the oxidation state of peroxide, the oxygen of peroxide is present in the -1 state. Here the oxidation state of this oxygen is -1. Here it is -1. So now let's move to another one. Here H2O2 we calculated as -1. Now here you see in water I have already calculated and I have shown you. In water here I calculated and I have shown it to you. In case of water I calculated and I show you that here the oxidation state is -2, because you see here H2 we do not consider the stoichiometric coefficient, we do not consider the coefficient, only the molecule is taken here. So 2 hydrogens, so that will be 2 into 1 plus oxygen we don't know, that will be X, and that will be totally equal to 0. So here it will be X is equal to -2. So here in water it is -2, and in case of this molecular oxygen we know from the rule that in case of molecular formula their oxidation state is always equal to 0. So here the oxidation state is 0. So that is why it is written the oxygen of peroxide is present in -1 state, is converted to 0 and decreases to -2 in water. So you see in the reactant phase, we had our oxygen present in only one oxidation state, which was -1. But in the product phase, I have two different oxidation states for oxygen. So this type of reaction is known as a disproportionation reaction. Disproportionation reaction means a special type of redox reaction where one element is reduced as well as oxidized. Both things are happening here. So you see, in both the cases, what is happening here? Here O2 was -1, it became -2 here. It was -1, it became 0 here. So from -1 to 0, it means that it has been reduced, and from -1 to -2, it means that it has been oxidized. So that is the happening here. That is what is happening here. Now in continuation to the previous one, I'll just show you using one more example that how this disproportionation reaction occurs. Suppose I have a reaction of Cl2 plus H2O, means here water is reacting with chlorine. Then you see, when water reacts with chlorine, two products are formed. One is your HClO, this is one product, and another product is your HCl. These two products are formed, and along with some molecules of water are there. Now we need to balance this reaction, but at this time being, I'll just omit the balancing part, or let me balance it. So it will be 2 here, and now the reaction is balanced. I think you see 2 chlorines are present here, 2, 3, 4 hydrogens, here 4 hydrogens, and 2 oxygens, and similarly 2 chlorines. So this reaction is balanced here. Now if you compare the oxidation state of all the atoms here, now what I say that those atoms which are present in the uncombined state or in the free state, they have their oxidation state 0, means the chlorine has the oxidation state 0 here. Now in this case here, how to calculate the oxidation state? We have to calculate the oxidation state of chlorine. So for calculating the oxidation state, I will take it as X. Now we know that the charge of hydrogen is 1 and oxygen is -2, and this will be completely equal to 0. Now when you will solve, you will get that x minus 1 is equal to 0, that is x equal to 1 here in this case. You will get x equal to 1, means the oxidation state of chlorine here it is +1. And similarly if you calculate here the charge of hydrogen is again 1, and plus chlorine we don't know, it is x, that is equal to 0. Now if you calculate the value of x, this will be equal to -1. Here the oxidation state of chlorine is -1. So in the reactant phase, your oxidation state was 0, but now in the product phase, you see you have chlorine present in two places which have different oxidation states. So here the oxidation states have changed by two different values. At one place it is oxidized, and at one place it is reduced. This is your oxidation here. This is oxidation because removal of electron is there, and here it is reduction because addition of oxygen is there. In this, addition of electron is there, sorry. In this case it is oxidation because here addition of oxygen, it is directly visible here, but addition of electron is there, and in this case it is addition of electron here. So here your oxidation number has changed. So this type of reaction is known as your disproportionation reaction. Now I'll be showing you more examples and how to calculate the oxidation state, because this is very important. Without the oxidation state you cannot balance the reactions. I'll show you some more examples for calculating the procedure of oxidation state. Let us see one by one. Let's see. Let me take one question. This question is from your NCERT textbook. Here it is NaH2PO4, and here you have to calculate the oxidation state of phosphorus. This phosphorus we have to calculate the oxidation state here. So now the technique is, the one for which oxidation state you have to calculate, that one you have to take as X, and remaining all we will write the charge of them. Then how many sodium atoms are present here? Only one. So we will write 1 sodium, and what is the charge of sodium? We know that Na positive, so it will be 1. Then plus, then similarly how many hydrogen are present? 2 hydrogens, so 2 into, again charge of hydrogen is 1, that will be 1, plus how many phosphorus? Only 1, and the oxidation state of oxygen is unknown to phosphorus is unknown to us. So we will write as X, then again plus, then how many oxygens are there? 4, then the charge of oxygen is -2, and since it is a neutral molecule, so this will be equal to 0. Now let's solve it. 1 plus 2 plus x, this will be plus into minus minus, 8 is equal to 0. Now if you solve here, you will get x minus 5 is equal to 0, that is x equal to 5. It means that your oxidation state of phosphorus in this case is plus 5. The oxidation state of phosphorus is plus 5 in this case. Let me take another example for you. Let us take H4P2O7. This example is given from the book, and here you have to calculate the oxidation state for phosphorus once again. So now once again the same technique. How many hydrogens are there? 4 hydrogens. So 4 into the charge of hydrogen is always 1 plus phosphorus. How many phosphorus are there? 2, and the oxidation state of phosphorus you have to determine, so that will be x. So 2 into x plus, then again here how many oxygens are there? 7, that will be 7 into the charge of oxygen is -2, that is equal to, now since this is a neutral molecule, this will be equal to 0 here. Calculated, 4 plus twice x minus 14 equal to 0. Solve it. Twice x minus 10 is equal to 0. It means that x will be equal to 10 upon 2, that is equal to 5. It means the oxidation state of phosphorus here it is plus. Now I will show you one calculation when there is a charge present on any atom. Suppose you have CO3 and 2 negative, and you are asked that what is the oxidation state of carbon in this case. Then let us see. We don't know the oxidation state of carbon here, so let it write it as X plus, how many oxygens are there? 3, so 3 into the charge of oxygen is -2, so let us write -2 equal to, this time here you cannot write 0 because the whole molecule carries a charge of -2, so here you have to write -2, and now you solve it. X minus 6 is equal to -2, so x will be equal to -2 plus 6, which is equal to -2 plus 6, which is equal to 4, equal to 4. So here the oxidation state of carbon is plus 4. Oxidation state of carbon is plus 4. So now once again I am going to tell you about disproportionation reaction, and then I'll be ending it here. So in disproportionation reaction, what happens? A same compound or a same element which is present on the reactant phase has different oxidation state, and on the other side, means when on the product side, it will have two different oxidation states. See, I'll be giving you the example of, suppose sulfur S8 plus suppose again H2O, and this has formed here H2S plus you have H2S2O3 and plus H2O. This is your compound, this is the product formed. Now you see here the sulfur is in uncombined state, means nothing has combined except sulfur here, so this one you will get the oxidation state 0 here. Now let us try to calculate the oxidation state in these cases. Let us try to calculate. Here the oxidation state, we know that 2 hydrogens are there, so this will be 2 into 1 plus x, that implies that x will be equal to -2. It means the oxidation state here it is -2. Now let us try to calculate here. This will be again 2 into 1 plus 2 into x plus 3 into -2, that will be equal to 0. Why equal to 0? Because this does not have any charge on it. Now this will be 2 plus twice x minus 6 equal to 0, that will be twice x is equal to 4. It means that x will be equal to 2. It means that the oxidation state here it is plus 2. Then now you see in the reactant phase you had sulfur atom present only in one oxidation state, but in the product phase you got sulfur atom which is present in two different oxidation states. So this type of reaction is known as disproportionation reaction. Thank you for watching the video up to here. Have a good day.